In this video, I want to go through my solution to this problem where we start at either D or E, and then we move in this direction up here and we count the number of lines and also count the number of different colors. So there are a lot of different ways to do this, and I'm going to show you mine. So again, as we're moving along here, we want to detect all the lines so that we can output the number of red, green, and blue lines, and also the total number of lines. I'm not going to do the optional challenge here, so it'll just be the task. So after I wrote this program, I wanted to see if I could understand it better, so I wrote a flow chart, and I'm going to go through this briefly. And I've already detected one error that I've since corrected, so if you see any errors, let me know. So okay, we're going to start, and then we're going to check to see if a bumper is pressed, and if it is pressed, we want to stop and just print out the color information. That means we've hit the wall on the far side over here. But if we don't sense a bumper being pressed, then we're going to move forward. So that'll be pink. And then is a line detected? Well, if it's not, then we just keep moving. Stay in this loop. If we do detect a line, we want to stop, determine what color it is, and increment a counter color, a variable that I've assigned to red, green, or blue. And then this is the area where I'm a little surprised, but it makes sense that you have to get out of the line. The line has a finite thickness, so if you immediately come back to this loop here, you're going to detect the line over and over again. So after we increment the color, again, we're stopped here. So we want to move forward and then determine if we detect the same color that we're on. So if we're on, say, red here, then I'm going to look for red, and as long as I see red, then I just want to come back here and keep going forward until I get out of red. So if I don't detect the same color, then I'm going to go down here and come across here and back up to the bumper pressed and come down there. So this is a program which lends itself to modular programming. By that I mean, so modular, that means you break it up into smaller entities. So this is my main program right here, just this part here, and you can see that all the red or pink blocks are different functions. So I've enclosed different functions inside different steps inside functions or blocks so that the logic of the main program is clear. So I set things up here, and then I go to D. I didn't know about the little method that allows you to go anywhere you want, so I had to drive there. And then while I don't detect a bumper press, I drive forward, and then I check for blue, check for green, check for red. Keep doing that until the bumper is pressed, and then I stop and generate the output. So the first function or block I have, I'll show them here. Again, this is the main program, and the first function, it does setup. So it clears all the rows in the output. It sets the color counters to 0, and it sets the drive velocity a little faster. So I could put this up in the main program, but it would just clutter up the main program and make it really big and unwieldy. So I've farmed it out into a function there. So again, as I mentioned, I didn't realize I had that nifty method to place the robot anywhere you want. So I had a little program that just says go to E, so you turn right, go forward, stop driving, turn left, just to get to the right place. And then while we haven't had the bumper pressed, we drive forward and then check for blue. So check for blue If down eye detects blue, then stop driving, increment the counter by 1, and then I've got a function within a function. So that is right here. So leave blue line, since that was very similar for each color, I farmed it out again to a function. So leave blue line says while the down eye detects blue, in other words, I'm on the blue line, just drive forward, and then when it doesn't, I'm out of it, and I drop down to here, which then moves on to the next one. So we'd have similar functions for green and red, identical except for the color. So when we finally hit the bumper, we're going to fall down here, and so that's going to give us the generate output. So this is just, print the number of red lines, number of green, number of blue, and then the total number of lines. So, this might not be the most efficient, there may be more elegant ways to do things, but I think this is a good program for the modular nature of it. In other words, lots of functions such that the main program is logically very clear what's going on, and you can encapsulate a lot of logic in the functions. So let me demonstrate one of these. So he's going to move over to E this time and just move up, and there's the data. So again, maybe the big takeaway for this program is to, let's see, where was I? Is to break things up a lot. That allows you to have a main program that's very simple so you can understand the logic, and then all the details gets farmed out to functions or blocks. Thank you for watching.